What's up, everybody? Welcome to Coding with Chaim. Would you like to ace your next React interview? If you would, then you've come to the right video. Okay, so I have 14 questions that I have prepared that I would use right now if I was to try to interview a new candidate for a React position and I wanted to kind of gauge their React chops. These are the exact 14 questions that now in the year 2020 I would ask a potential candidate. So what I'm going to do is I'm going to break it down into two separate videos. Within this first video, we're going to cover the first 7 questions. And then the next video, which will be next week, we're going to cover the next 7 questions. Let's go ahead and jump into the first question. The first question is, what is unidirectional data flow in React, right? So we always know that in React, we always say that data only flows in one direction. What does it actually mean? So to kind of illustrate that point, we can actually take a look at a code example that I have right over here. So you'll see here, I've got a basic function called app, which is just a simple component that renders this one single input right over here. And then we're defining the state variable, which we're creating using the useState hook, and we're initializing that to be an empty string. Finally, down in the input, I'm basically taking the state variable and I'm binding it to the value prop within the input. And then on change, I'm going to go ahead and pass it this handle change function right over here. But what you'll actually notice is that right now, this handle change function is not actually doing anything. It basically has an empty body. Now watch what happens when I actually try to type into this input. As I try to type, you'll actually see that nothing is in fact happening, even if I'm trying to type into the input, right? And so this kind of illustrates what unidirectional data flow actually means. In React, whenever you're trying to actually type into the DOM itself doesn't actually update state. So to contrast that, you may or may not be familiar with Vue, but even if you're not, this concept will still kind of make sense. Vue has something called v-bind. And basically what that means is that you can actually take a piece of your data, such as state, which they basically call, I think, the model, right? And then you can basically bind it to an input. Now the model can update the inputs. In other words, if you actually change the value of your state, of your JavaScript value, it'll actually get reflected in the actual DOM. But what could also happen is, if you're actually updating the DOM, the model also gets reflected. They're basically bound in both directions, which means the view can update the data or the data can update the view. But in this example here, what you're actually noticing is in React that's not the case. The only thing that gets reflected on screen is the value that's within your state. In order for you to actually change what you see on screen, you have to change the data. The screen or your DOM or your view can never actually change the data. If you want to change the screen, you got to change the data. So in order to actually fix this bug that I have right now where I can't actually type, I have to actually go into my change handler and actually use my setState method right over here that I got out of the hook and actually pass it the e.target.value. And now I can actually come back here and I can start typing, because basically what's now happening is on every single key press, I'm actually updating the value in state, and then that state is now getting reflected in the DOM, but the DOM at no point is actually updating the state. That's what unidirectional data flow is. So the next question is, what is the difference between props and state? So state is basically when a component defines data locally within itself, and props is when that same data then gets passed down to another component. So let's actually see this in action right now. So you'll see here we actually have a component called app. App is actually going to go ahead and render child, and then child actually goes ahead and renders grandchild. Now this is actually just a sort of a hangover of a snippet of code that I have for a different example, which is why we actually have the app, child, and grandchild. But the point still stands that here inside of the app component, this value data that we have, this value variable that we have here inside of the app component is actually state. The reason why this is state is because the app component itself is the one that basically defined it. And it also actually has a set value function, which means that the app component actually has a way to actually change this bit of data. So effectively what that means right now, what we're seeing so far is that if a component itself is defining a new bit of data within itself, A, that's called state, B, that component can actually go ahead and manipulate that bit of data. On the other hand, in the child component, we're basically taking this value that we have defined here as state, and we're then passing it down to the child component. The child component can then go ahead and access that using the props argument that gets passed into it. So basically, in order to access this value, we have to go ahead and say props.value. So what this shows us now is that props is when that same bit of data gets passed down to another component. The receiving component now is receiving that data as something that is called props. So props is data that gets passed into another component. And the fundamental difference that exists between props and state is that state can actually be changed, manipulated, and mutated, whereas props cannot be changed. In order for you to change props, you have to actually have your child component go back and call up to the parent component to ask the parent to go ahead and change that bit of data. The next question is, what does it mean when we say in React that we're going to be lifting state up, right? The React documentation actually talks about this concept of lifting state up. What does that actually mean? To kind of see this in action, let's take a look at this code snippet right over here. So what you'll see again is I have a basic app component that is rendering a list component and an item count component. Also, the app component is going to go ahead and initialize an array of random strings, foo, bar, and baz, which it then basically passes down to the list component. The list component will accept this via props and then just go ahead and render foo, bar, and baz right on screen. Then we also have the item count component, which is also trying to utilize this actual items array that we have on state right over here. So in other words, the list component is actually taking the entire items array and rendering each individual item out. What the item count component is doing is it's actually just trying to render the number of items that we have by simply saying items.length. So in other words, we're just trying to render the amount of items that we have within this particular array. But the point here is that we actually have two child components which are kind of siblings one to another, and what they're both relying on is the same bit of data. So in order for us to actually make sure that they can both rely on the same bit of data and sort of stay in sync without us having to sort of manually do any kind of logic to keep them in sync, what we can do is we can basically make them siblings under the same component. And that's exactly what I've done right over here. The app component both renders the list component as well as the item count component. And so now what ends up happening is, since they are both sort of subscribing to the same bit of state that lives here inside of the app component, this items array, now they're in sync by default, because whatever happens to the items array is going to happen both for the list component as well as the item count component. So effectively, what lifting state basically means is if you ever have more than one component that's trying to share the same amount of data or the same bit of data as another component, take both of these components that want to share this data, put them together as siblings inside another component that lives on top of them. So you might have like some kind of a parent. These two are going to be the same children of the same parent component. So in other words here, item and item count, or list and item count, are both children of the same parent component. Therefore, they can both utilize the same bit of data, and they're going to basically be in sync by default because they're using the same bit of data. The next question is, what's the difference between a controlled component and an uncontrolled component? So let's actually take a look at another code snippet to kind of see what the difference between these two are. So if we see here, I have the app component that's rendering the controlled component, and then as well as an uncontrolled component. Let's take a look at the controlled component first, and this one should seem pretty familiar to you if you've written React for any amount of time. Basically, all we're doing is we're rendering an input component that's going to be bound to this bit of state right over here. So in other words, we're using the useState hook to define state. We're starting it as an empty string. This state now is just an empty string. We pass this state down as a value to the input. So effectively, this input is now tied to this bit of state. And then we have the onChange function. Every single time you're basically typing into the input, we're going to go ahead and call setState with the e.target.value, effectively updating the value of the state. And then finally, we have a button that simply says click me. So whenever I type into the actual input right over here, I can click it, and then I simply get an alert that actually gives me the output of what I've just typed into the input. So this is a controlled component. On the other hand, an uncontrolled component is basically where you're not actually binding a bit of state to your component. So here in this input component, back in the controlled component for a second, the input is actually bound to the state value. Whatever the value is inside of the state variable, that's what's going to get reflected on screen. That's what the input is actually going to display. So the input is effectively tied. It is being controlled by the data. On the other hand, in the uncontrolled component, what you'll notice is this input over here doesn't actually specify neither a value nor an onChange. It's not actually bound to any bit of data. That's what an uncontrolled component is. So again, a controlled component is bound to data, whereas an uncontrolled component is not bound to any bit of your state or doesn't have any kind of onChange. Then the question, of course, might be, how might you actually get this value out of an uncontrolled component? And the answer is that that's where refs might actually come in handy. So basically, a ref is basically going to be the sort of escape hash that you can attach to the underlying input. And by the way, I actually have a video sort of exploring refs in more detail. If you want to take a look at that, I will leave a link to it down in the description box below. But the basic idea here is that what we're going to do is we're going to take this input ref and we're going to pass it to this ref attribute right over here. So now what happens is in this alert value function, instead of having to dig out the value of state, what we can do is we can actually get a hold of the underlying DOM node and simply read its basic JavaScript property known as .value to actually get its underlying value out of it. So again, this is an uncontrolled component because it's not actually bound to anything in state. This is a controlled component because it's literally being controlled by your state. Okay, so this next question actually touches on a topic that we sort of briefly touched on before, and this is basically what are refs in React, right? And so to kind of see what refs are, we can actually take a look at this little code snippet that I have right over here. And again, just as a reminder, if you want to see more about refs, I actually have a video dedicated just to that topic. But to take a look at what refs are here, what we're doing is very simply. We have a simple input component or a simple input element that we're rendering right over here. We're creating an input ref using the useRef hook. And then what we're doing is we actually have every JSX element actually has this ref attribute that you can basically pass a ref. So in other words, whatever ref you're actually creating from within the useRef hook, you can take that exact variable that you've created and then pass it to this ref attribute on the JSX elements. And then what this allows you to do is to kind of actually give you an escape path to start manipulating and interacting with the underlying DOM node. So really quickly, the idea basically is that us as React developers, we're not really talking to the actual DOM. We're sort of more developing against the virtual DOM. But in certain instances, we actually want to get a hold of the underlying DOM node. We want to kind of bypass the virtual DOM and manipulate the actual underlying DOM. And so React kind of gives us this escape hatch known as rest that kind of allows us to do this. One such example where you might actually want to do this very thing is when you're basically trying to set focus to an input. So you'll see right over here, I have this input. If I click into the input, the actual outline around the input turns blue. Now what I would actually like to do is, I would like to programmatically set focus to this input. That, in other words, as soon as the user actually comes to the screen, without them actually having to click into the input, I want it to already be set focus programmatically through my own code. And as it turns out, in regular JavaScript, this is very easy to do. You can just call the .focus method. In order for us to do this in React, we basically have to use a ref to get a hold of the underlying DOM node, and then on the underlying DOM node, go ahead and call the focus method. So let me show you that in code. Right over here, we can just go ahead and uncomment this bit of code. We're going to go ahead and say input ref.current. So if you want to actually get a hold or read out the value that is actually being stored inside a ref, you have to actually use the .current property. So every single ref that you create using the useRef hook actually has a property on it called .current, which basically stores the actual value. At this point, inside of the use effect, this already happens after the component has been done rendering. So now the input has already been, mounted into the DOM. So now input ref.current will actually go ahead and represent my actual underlying DOM node, the actual input. And now I can just go ahead and call focus on it. And now if I refresh this iframe, you'll now see that without me actually having to click into the actual input, you'll already see that it actually has the blue outline. And that happened because I called focus on the actual input itself. Okay, so this next question is, what are keys and why are they important when we're trying to render lists within React? And so basically to answer that, first of all, what are keys? So whenever you're trying to actually iterate over an array of items to try to sort, in other words, let's say you have an array of cars, and for every single car you want to kind of go ahead and create a new li within your UL to kind of render out the list of all the cars that you might have within your array. So what happens is for each li you have to basically give it a unique key identifier, right? So that's what the keys are. It's a way for React to sort of be able to uniquely identify each individual item within your array. So in other words, instead of React having to look at the data to identify each item, it actually looks at the key that you have given each individual li within your UL, and that's how it can uniquely identify this. Now, why is that important? To kind of see why this is important, let's actually take a look at a snippet of code that we have right over here. So what I've done is I basically created a data array. Now I actually have the console open for an important reason, so let's get to that in just a second. But basically what we have is a simple data array. I have a for loop where I'm kind of iterating over until the number 10, and then for each one I'm just going to go ahead and push in the actual number. So we're going to basically create an object that's going to have two properties on it, the number, which will just be I, and then we're going to have a ID, which will just basically be the string ID plus the actual number. So that's going to give each one a unique ID. Okay, and then very simply in the app component, we're just going to go ahead and take this data array that we just initialized, and we're going to initialize our state variable to be equal to this data array that we just created within that for loop. And now what happens is down here, we actually go and we iterate over the array. So we're basically going to go ahead and say state.map. And then for each one, we're going to go ahead and render this item component. And then right now, the key is actually set to end.id. But let's actually change that and make it so that the key will actually be equal to the index. Because this is actually a pretty common pattern that a lot of people do. And it's actually wrong. The React documentation very much recommends that you don't do this. And we're going to actually see exactly why it's important not to use an index, but to actually use some sort of unique identifier for each individual key. But right now, let's actually do this example where we're actually going to use the index as a key. And it's also important to note that if you ever forget to specify the key, React will basically just give you a warning that says, hey, by the way, you forgot to give me keys. So what React is going to do is by default just go ahead and use the index anyway. So by you actually supplying the index or leaving off the key entirely, the result will be the same. And that could sometimes have somewhat detrimental effects, as we're soon going to see. right? So then what's going to happen is we're going to go ahead and render this item component. The item component has an h1 that simply renders the props.number. And then if I click on the actual h1, it's going to go ahead and call the delete function, which we're basically passing down via props. And all this delete function does is it accepts the ID of the individual number. We filter it out from the array, and effectively we're going to go ahead and delete that individual item. So now what I want to basically show you is as follows. If I actually come here to the 0th element, or in other words, the first element within the array, the number 0. Now watch what happens. Maybe let me just make this a tad smaller. Now watch what happens to the entire list right over here in the DOM element. So your eye should be focused here. I'm going to go ahead and click on one of these elements. I'm going to delete it and watch what happens. And you noticed how pretty much everything flashed purple. Basically, what that means is that everything right now inside of this entire list got repainted on the screen. But if I make one small change, let's now no longer set the key to be equal to the I. Let's rather have the key be equal to n.id. Right? Now let's go ahead and refresh this iframe browser. And now once again, your eye should be focused here on the actual elements within my console. I'm going to go ahead and once again only delete the 0th element within the array. And now watch, as you can see, that literally only the div flashes and pretty much nothing else flashes. So what actually happens? Well, as it turns out, React, when it actually tries to make changes to the actual DOM, it tries to do this in the most efficient way possible, right? So this is where the sort of reconciliation algorithm kind of comes into play. React looks at your current tree, looks at the new tree that it's going to try to render right now based on your change that you've done to your state, based on the sort of new JSX that you're going to have based on the new state values, and accordingly try to take the new tree and commit it to the actual DOM in the most efficient way possible with causing the least amount of paints necessary. So here what's happening is, and I'm actually deleting an item out of the array, all the items that are coming after that particular item are now going to have to shift up. So basically their indexes have effectively changed. So the same data, the same bit of data, in other words, the same number 1 or the same number 2 is still there, but the index is now in a different spot. So in other words, the number 1, which used to be at index 1, is now actually going to be at index 0. So what happens is React sees this and sees that all the keys have actually changed. So what React now thinks is, oh, that means that the entire tree is new. I have to go ahead and recreate an entirely new tree and actually force them all to kind of get repainted, when in reality that's not the case because the data is still the same. React's not looking at the data, it's actually looking at your keys. So to kind of prevent this problem from happening, what React kind of wanted to do is to give it a unique key identifier that is not the index, one that won't change even if the data is actually changing, which is why when you're actually using an ID, even if the actual data is still changing, but since the IDs are always going to stay the same, the number 1 will always have the ID of 1, the number 2 will always have the ID of 2, no matter what the index is, no matter where they find themselves in the array. Now, only the actual item that I'm actually going to delete will actually get painted, and so far that it'll sort of get destroyed, and that's pretty much it. All the other things that are still the same, which React will know is still the same because their keys are still the same, will basically still remain in effect, and they're not going to get repainted again. That's basically what keys are and why they're important. The next question is, what is context? So context is a mechanism that allows us to actually pass data from one component down to another component, right? So that sounds a lot like props, but one of the sort of key differences, or the key difference between props and context, is that props really only goes from one component down to the next component. So a parent can take data and pass it straight down to his child. Now, if the child wants to take that component and pass it down to its child, now it can do that. Which basically means that if you want to take data that goes from the parent down to a grandchild, it has to actually go through the child's component because props can only be passed down one level at a time. On the other hand, context is this new mechanism that allows us to actually pass data from one component down to as many components deep as you want to within that sort of same tree. So let's actually see that in code. So here you can see on screen, we basically have a relationship of components that looks a little something like this, or a hierarchy of components that looks like this. We have the app component, which will render the child component. The child component will then go ahead and render the grandchild component right over here. And so the goal is for us to actually have this number 1 rendered on screen. Grandchild is the one that's actually going to go ahead and render this component that basically returns an h1 and simply reads out the value of props.value. Now this value comes over here. So the app component basically takes this number 1, passes it down to a prop as a prop to the child component. The child component will accept it via props, and then pass it down further to the grandchild by saying props.value. So here what we've effectively done is we've pretty much bothered the child component to pass down the value to another component, and it never really needed it itself. The whole reason why the parent component, app, actually even had to give the child component this prop is just for the sake of passing it down to the grandchild. This is sort of known as the concept of prop drilling. We're basically trying to drill this prop down to a level deeper, and so we're actually having to go through the child component just to kind of get to the grandchild. Context, however, solves exactly this problem. So let's take a look at that. So here we basically have the sort of same structure. We basically have the app component, which renders the child component. The child component then goes and renders the grandchild component. But what you're now going to notice is the child component is now no longer actually getting the props, right? So they're not actually passing a prop to the child component. And in fact, here within the child component, we're not actually passing any props down to the grandchild. Instead, what we're doing is we're basically creating this context object by calling the react.createContext. We're then sort of wrapping our entire component or entire sort of application. In this case, it's a tiny application. We are wrapping our entire application with this context.provider. And so then we're basically going to take whatever value we want to pass down and set it on this value property on the context.provider. So again, we're just trying to pass down the actual number 1. Now in the grandchild component, what we can do is we can use the useContext hook to sort of subscribe to this bit of context right over here. In other words, this very same context we just created right over here. And then we can literally go ahead and read out that actual value right over here. So again, the grandchild is now going to go ahead and render an H1. It's going to go ahead and render this number 1 right over here by simply passing the value of context. So context here, this might have been poorly named. This maybe should have just been named value. I can literally just read out the value straight out of the context, and we're just going to go ahead and render the number 1. And what's actually very important now is you can actually see that the grandchild or the child component has been completely undisturbed. It is not accepting any props. It's not passing any props. We were able to go straight from the app component straight down to the grandchild component and directly give it the actual value that it needs without having to bother any of the components that kind of sit in the middle of the hierarchy. And that's kind of the power of context. Well, that does it for this video. Hope you enjoyed it. I hope you found it useful. If you did, please drop a like, subscribe, and I'll see you in the next week's video, which is going to be part 2 of this actual React interview question. So if you don't want to miss that, definitely make sure that you subscribe to the channel.